All right, in number 9, they want us to confirm that the circumference of a circle of radius a is 2 pi a. All right, so if we look at this circle here, we should know at this point in time f of x, or y, is equal to the square root of a squared minus x squared. Because this is a circle of radius a, so its original equation is x squared plus y squared is a squared. And we solve it for y. It's centered at 0, 0, has a radius of a. So we could use the arc length formula, but it has vertical tangents at plus and minus a, and the derivative would be undefined, so the arc length isn't going to work there. We could use symmetry. We could find the length of 1/8 of the circle, go from 0 to a over the square root of 2, and we're getting that by drawing in 45 degree, or pi over 4, and dropping down the triangle. And because this is pi over 4 and this is a, this is one of those 45, 45, 90 triangles from geometry. This is a over the square root of 2. So we could come up with the derivative. Let me go back and look at it. Yes, hang on. The derivative of our function, which would be 1/2 a squared minus x squared to the negative 1/2 times negative 2x, which would clean up to negative x over the square root of a squared minus x squared. And then use the arc length formula and go from 0 to a over the square root of 2. And the arc length formula is 1 plus the derivative squared. So I'm squaring negative x over the square root of a squared minus x squared. Which, let's see, square root of 2, turns into the square root of 1 plus x squared over a squared minus x squared. Putting this all as one fraction, we would get, yeah, I think that's what we're going to do, one fraction. We'd have the square root of a squared minus x squared plus x squared over a squared minus x squared, 0 to a over the square root of 2. That's just going to be a squared, but I can take it out of its root, it's just an a. And a is a constant, so we can come in front. Oh, now this looks like an arc sine. This is the arc sine of x over a. From 0 to a over the square root of 2. So now I plug and chug. We get a, the arc sine of a over the square root of 2 over a is just 1 over the square root of 2 minus the arc sine of 0, which is just 0. And when is the sine 1 over the square root of 2? Rationalize square root of 2 over 2, that would be pi over 4. So I get pi over 4 times my a, but that was only 1/8 of the circle, so if I take that and I times it by 8, I get 2 pi a for the circumference of the circle. So we have proved it. That concludes 7.5.